All right, here's our video today, Algebra 2, adding rational expressions. So what are rational expressions? Well, let's write it down. It's a simple definition. Basically, it's when you have fractions that have variables in the denominator. That's a rational expression, right? So if I had, let's use green, see how that works. 3x. So you see the x right there, you see that variable in the denominator. Well, that's a rational expression, right? So we can add them, and just like fractions, when they have the same denominator, well, you can keep the denominator, right? For example, let's say we had 3 over 2x plus, let's say, 5 over 2x. You see how they have the same denominator, so we keep the denominator, just like when we add normal fractions, right? And 5 plus 3 is 8, so that'll be the answer there. So, and let's do one more. So what would this be? 2x, 2 over x plus, let's say 5 over x. What's that answer? You got it, 7 over x. They have the same denominator. But of course, what if they have different denominators, unlike denominators? So let's talk about that. Let's get a clean page. All right, what do we use today? Why don't we use white? So what if we have, again, unlike denominators, right? Let's say we had 1 over, well, white's not going to work. No, definitely not white. Let's use black. 1 over x plus 1 over x plus 2. So they have unlike denominators. So what the first thing you want to see is, you want to say to yourself is, what is missing? What is missing in the denominators? Well, in this one right here where the arrow is, we're missing x plus 2. So we'll just put an x plus 2 up there. That's what we're missing up there. And over here, we're missing x. So you look at what they're missing as far as the other denominator. That's the key. What are they missing? And then we can multiply that, x plus 2 times 1, which you know the answer for that. And we're going to do x times 1, which you know the answer to that also. And then just combine the denominators. Because remember, the lowest common denominator, the common denominator here would be both of them because they're different. So it'll be x plus 2. So we're not done yet. Let's clear this out on top here. So we know that x plus 2 times 1 is just x plus 2. And x times 1 is just x. Of course, we keep that denominator. And then just combine like terms. What do you think the answer will be? We have two x's here and a 2, so that'll be 2x plus 2. And we keep the denominator. They were different denominators, so we put them both together. And there's our answer, right over here. So we'll do a few more so you get used to it. Rewind if you need to. Let's clear this out. Let's do another one. All right, let's try this one. What if we had 2x over x plus 2 over x plus 2? So again, ask yourself, what is missing? What is missing? Well, in the first fraction, what's missing is x plus 2. And in the second one, what's missing is x. So we're going to put x plus 2 times 2x plus 2 times x, which we already got there. And of course, we're going to combine the two denominators. And what do we get here? So if you distribute this, what do you get? You're going to get 2x squared plus 2x, plus you already have a 2x. 2x squared plus 4x, not 2x. Fix that. Always be careful in math. Double check. 2 times x is 2x squared, and 2 times 2 is 4x. Make sure we have that down. And of course, we have the same denominator. And then we can combine like terms here. So we're going to have 2x squared plus 6x over x plus 2. And of course, we can also reduce this if we need to, right? Let's bring it down here, bring an arrow over here. So we know we can take out a 2 and the x, and then we're going to just have x plus 3, right? We're just factoring here. Again, if you want to double check, just distribute. 2x times x is 2x squared, right? And 2x times 3 is 6x. Right? And then we just have our x plus 2 over here. And guess what? Right? We can reduce 2x divided by x. It'll just give us 2, right? Because the x's will cancel. And so we'll be left with 2x plus 3 over x plus 2. All right, let's do a few more. Keep that up for a few seconds. Rewind if you need to. Let's clear it out. And let's do another one. Why don't we do, let's see, what number? 3x over, let's do x minus 2, plus 2x plus 4. Why don't you try that yourself? Pause the tape. What are you asking yourself? What is missing in the denominators? What do you think? Well, we know what's missing with this one. The x plus 4 is missing on this side. And here the x minus 2 is missing on that side. So you're going to have what? 3x times x plus 4. And over here you're going to have 2 times x minus 2. And of course we're going to keep the denominators together because they're different. And what do you got? So if we distribute this, and be careful, so easy to make mistakes. What do we get? We get 3x squared, because 3x times x is 3x squared. 3x times 4 is going to give us 12x. 2x, 2 times x is 2x plus 2x. And 2 times negative 2 give us negative 4. And we have to combine like terms, right? Keep that denominator. So let's clean this up. And over here, we're going to get 3x squared plus 14x minus 4 over x minus 2, x plus 4. There we have it. Why don't we do one more? Clear that out. See how yellow is. Change the color. How's this? Yeah, that's better. 3x minus 1 over, do a quadratic here, x squared plus 3x plus 2. And we'll add that to 3 over x plus 2. So let's clean this up a bit. Let's clean this out and try to make two binomials, if you remember how to factor quadratics. So we're going to have 3x minus 1 over, oops, should erase that, but 3x minus 1. Now, if you remember in quadratics, very simply, you have, this is the c term, that's the b term, that's the a term, right? What two numbers will give us a product of the c term? 2 times 1, right? And 2 plus 1 gives us 3. If you don't remember how to factor quadratics, I have videos on that. But this would factor to x plus 2 over x plus 1. I'll just briefly show that again. Remember, what two numbers right here equal 2? Well, 2 times 1 equals 2. And we want them to sum to the b term, which is 3. So 2 plus 1 equals 3. So that's why we're using this. And then we'll do 3 over x plus 2. Now, what is missing? What's missing? Be careful here, because over here, the x plus 1 is missing. Right? The x plus 1's missing over here, but nothing's missing over here. There's nothing missing, right? It has an x plus 2. So we're just going to keep, make a little box. We're just going to keep the 3x minus 1. It's going to keep 3x minus 1. And over here, we have 3 times x plus 1, which gives us 3x plus 3. And of course, it's going to be over x plus 1, x plus 2. We don't have to put x plus 2 twice because they're sharing this one, right? So let's clean this up. What would you get if you clean that up? Well, you have 3x, and they have another 3x, so that's going to be 6x. And you have a minus 1 plus 3. Minus 1 plus 3 will give us a plus 2. And this is all over x minus 1, x plus 2. So that's how we add rational expressions.